Hi future doctors, welcome to the next class. We were discussing expansion of solids. In that more models we will see. If two different vials of L1 which is made up of one material alpha 1, another vial of L2 which is made up of alpha 2. Now both are at same temperature. So T1 degrees Celsius, T1 degrees Celsius. Now, how they will ask means they have raised its temperature in such a way that they are having same increase in length. What is the meaning of same increase in length? Now, what is the difference in length of this two vials means L2 minus L1. This difference, let us assume, I am giving as example 1 meter, 2 meters. Otherwise 3 meters you can take. Now what is the difference? 3 minus 1, 2 meters. Now both temperatures raised. So some 20 degrees Celsius to 40 degrees Celsius. Now its new length, this is going to increase. 1 meter is going to become 1.5. At the time, this 3 meter should become 3.5. Now again, what is the difference? Difference should be 3.5 minus 1.5, 2 meters. The difference should be constant. That is the condition. For same rise in temperature, rise in length also should be same. What is the condition for that they will ask. So whenever its temperature is rising from T1 to T degrees Celsius, its new length is going to be L1 dash. Its new length is going to be L2 dash. Now, L2 dash minus L1 dash should be equal to L2 minus L1. That one only we will assume X. The difference should be constant. For same rise in temperature, temperature is rising from T1 to T, T1 to T, isn't it? At the time, how we will write final length? L1 dash is equal to L1 into 1 plus alpha 1 T minus T1. Same like that, L2 dash is equal to L2 into 1 plus alpha 2 T minus T1 because both are at same temperature. Now, subtract these two. L2 dash minus L1 dash is equal to L2 into 1 plus alpha 2 T minus T1 minus L1 1 plus alpha 1 T minus T1. So, after expanding L2 plus L2 alpha 2, this one I am writing delta T minus, you can expand L1, L1 alpha 1, this one I am writing delta T, T minus T1, T minus T1, both are same delta T. Now, what is L2 dash minus L1 dash I have taken here? Increase in length, that is going to be X. What is that increase in length means? 3 minus 1, that is 2 meters. L2 minus L1, that is 2 meters. 3.5 minus 1.5. L2 dash minus L1 dash, that is also 2 meters X. Therefore, this formula L2 dash minus L1 dash equal to L2 minus L1. L2 minus L1 plus L2 alpha 2 minus L1 alpha 1 delta T. I have taken common here delta T. Now this is X, this is X. Therefore, these two will be cancelled. After cancelling these two, what will be remaining? So 0 is equal to L2 alpha 2 minus L1 alpha 1 delta T. So L2 alpha 2 is equal to L1 alpha 1. So L2 by L1 is equal to alpha 1 by alpha 2. This is the condition. What is the condition there? I am writing this side L2 by L1 is equal to alpha 1 by alpha 2. So this is the condition for same rise in temperature. For same rise in temperature, same rise in length. For that, this is the condition. After this, they may ask like this one in any way. So let us assume L2 by L1 minus 1, alpha 1 by alpha 2 minus 1. Both sides we made minus 1. Then L2 minus L1 by L1 is equal to alpha 1 minus alpha 2 by alpha 2. So what is L2 minus L1 we came to know? X. Therefore, X by L1 is equal to alpha 1 minus alpha 2 by alpha. Then what is initial length L1? They will ask alpha 2x by alpha 1 minus alpha 2. So like that they will ask L2 also. So if they are asking L2, L1 you got alpha 2. Now L2 here you will get alpha 1x by alpha 1 minus alpha 2. So if you want you can cross check. Here we made plus. Sometimes they will make here we made minus. Sometimes they will give plus. L2 by L1 plus 1, alpha 1 by alpha 2 plus 1. So what is the ratio of L2 plus L1 by L1 they will ask. At that time alpha 1 plus alpha 2 by alpha 2. Here L1 is coming means alpha 2 is coming. So like that they may ask anything. But condition is for same rise in temperature, what is the same rise in length they will ask. At the time you should solve like this. You should remember this final equation. This is the final equation. L1 alpha 1 equal to L2 alpha 2. So for the same problem, they will ask for same thermal stress they will ask. What is the thermal stress formula? F by A is equal to Y alpha delta. So for same rise in temperature, same thermal stress means, so F by A is same, delta is same, T is same. Therefore, they will write condition Y1 alpha 1 equal to Y2 alpha. So for same thermal stress, Y1 alpha 1 equal to Y2 alpha 2. For same rise in length, L1 alpha 1 equal to L2 alpha 2. Like that logically, if you remember, definitely you will remember. Otherwise, you will forget. Next, if it is having two different rods, L1, L2. So these two rods at same temperature, T1 degree Celsius. This is made up of alpha 1, alpha 2, another material, iron, copper. Then alpha 1, alpha 2 are different. Now its temperature rises from T1 to T2 degree Celsius. Then what is the increase in length they will ask. So what is the increase in length formula for this individual rod means delta L1 is equal to L1 alpha 1, its temperature increases from T1 to T2. So increase in load for this delta L2, L2 alpha 2 temperature rises from delta T2 minus T1. Therefore, total length increase. Delta L is equal to delta L1 plus delta L2. So, L1 alpha 1 plus L2 alpha 2 into T2 minus T1. This is one model they will ask, isn't it? Next, both are at different temperatures, T1 degrees Celsius, T2 degrees Celsius. Alpha 1, alpha 2. Two different materials at two different temperatures, but same length. Length is going to be same if you observe. Now let us assume this is 2 meters, this is 2 meters. Now we are increasing the temperature T1 to T, T2 to T. So different temperatures it is 20, 30. Whenever it is temperature increases, its length also going to increase. Whenever its length is increasing, again after what temperature, both the lengths are going to be same they will ask. L1 dash should be equal to L1 dash. Final length should be same. Again after what temperature, their lengths are same. Initial lengths are same at some different temperatures, 20, 30 degrees Celsius. Again, at some common temperature, the lengths are going to be same, they will ask at what temperature. So at that time, what we will do means, so for all the same formula, L1 dash equal to final length formula. L2 is equal to L1 into 1 plus alpha T2 minus T1. This formula you have tried two times. L1 dash equal to, what is the initial length here? L1, 1 plus alpha 1, temperature difference T minus T1. Now again, what is this L1 dash? Because lengths are same. Initial length L1. 1 plus alpha 2 T minus T2. So alpha 1 why we wrote differently means they have given different materials. If they give different length means we will take different lengths here. Now these two are same they said. Therefore, if we equate, these two are also equal. So L1 into 1 plus alpha 1 T minus T1 is equal to L1 into 1 plus alpha 2 T minus T2. So L1 will be cancelled. So 1 also will be cancelled. Therefore, final equation alpha 1 T minus alpha 1 T1 is equal to alpha 2 T minus alpha 2 T2. You have to find temperature. So, alpha 1 T minus alpha 2 T is equal to alpha 1 T1 minus alpha 2. So, common temperature. So, this is the formula. So, all these formulas we are getting. So, alpha 1 T1 minus alpha 2 T2 by alpha 1 minus alpha 2. So, all these formulas we are getting from main formula. This is the main formula. Final length is equal to L1 into 1 plus alpha T2 minus T1. So, these models you may get for your NEET exam, and sometimes they will give options, sometimes they will give problems on these equations. You can practice on these equations, definitely you can solve well. Thank you.